Okay, good morning. So in today's lesson, we're going to be starting to look at calculations that involve using solutions and the idea of changing concentrations. And this will happen when chemical reactions take place in solution. Okay, so key point is that you're going to be basing your calculations that involve concentrations and solutions around this version of our formula. Again, we're familiar with what moles is now. Moles is in there. So basically, number of moles equals, according to this triangle here, C times V, okay? Number of moles equals concentration times volume. That would mean, for example, that number of moles divided by volume equals a concentration, and then volume equals number of moles divided by concentration. So you've got three ways to organize that equation. Hopefully that all makes sense to you. Remember, N is representing number of moles. The unit for that is mole. Unit for concentration is moles per decimeter cubed. And the unit for volume is decimeter cubed. Now, a decimeter cubed, this is very important, is 1,000 cubic centimeters or 1,000 milliliters. 1,000 centimeters cubed. And that's going to be really important because you may have to convert between units when you've got whatever data given to you in a question. Okay, so there's three ways to organize that formula, like that, and like that. Now, a lot of the time you will have questions that involve using this equation that are based on data that you've got from titrations. And that's why I made watch that YouTube video in yesterday's class, to understand how to do a titration and how you use titration data in order to do calculations. So here's a very simple example. The question asks, calculate the concentration of sodium hydroxide if 250 centimeters cubed of a solution contains 2 grams of sodium hydroxide. Okay, so we've got to look at this data and then decide, well, how are we going to calculate the concentration here, okay? What data have we been given and how are we going to use that data? So my approach would be, while I'm getting familiar with it, okay, so I'll outline the data given. So that is the volume data, okay? And we know that the volume is 250 centimeters cubed of sodium hydroxide. So I might write sodium hydroxide. What do I know about sodium hydroxide? Well, I know the volume is 250 centimeters cubed, okay? Now I have to be aware that I will have to convert that if I'm using the formula I just mentioned, because we need to use decimeters cubed, but I'll leave it like that for now, okay? Concentration of that, I don't know, it's the unknown. Let's put a question mark there. Right, what else do they know? Well, they've told us that that to make this solution, 2 grams of this solid was dissolved in, okay? Because essentially that's what a solution is. You've got a solid that you've dissolved in a certain amount of water, okay? So we've got the mass of sodium hydroxide in that amount, and the mass is 2 grams, 2.0 grams, okay? So you're going to need to approach this by using the previous equation that we used when we are dealing with masses only, and then that will give you all the data you need to calculate the concentration. Okay, so I've written down in steps here how do you do it. First, you're going to need to convert grams to moles, and we'd have to use our original formula, the first one that we learned, which is number of moles equals mass over molar mass, which in this case, remember, we're talking about sodium hydroxide. We'd have number of moles equals 2, which is the mass in grams, over the molar mass of sodium hydroxide, which we'll have to calculate. Let's do that here. So we've got the MR of NaOH. You check your periodic table. Sodium is 23, oxygen is 16, hydrogen is 1. So we've got 73, 36, that's 40. Okay, so sodium hydroxide has a mass of 40, which means that 1 mole of sodium hydroxide weighs 40 grams. So we put 2 over 40. This, just in case you're unsure, this has come from here. This is where that 40's come from. The 2 has come from here. Do an arrow there. Okay, and that will give us the answer 0.05. I should have been able to do that in my head, but as I've always been saying, you don't have to be good at maths to be a good chemist. We've got 0.05 mole. And then we know the number of moles of sodium hydroxide, so I'm going to add it to the data here, okay? I can put mole, or I can put N, sorry. N really would be the symbol I should be using there, because that's what we've been using all along. So N equals 0.05 mole. Okay, so now you'll probably see that you've got two pieces of data. We've got the volume here, and we've got the number of moles, which means we can now use this formula, the one that I just outlined at the start of the lesson. Number of moles equals concentration times volume. Number of moles we know, it is 0.05. Concentration is our unknown, so I'll just leave it as C, times the volume, which is 250, but I need to make sure I convert that to decimeters cubed, okay? Now, obviously, if there's 1,000 centimeters cubed in 1 decimeter cubed, then I'm going to have to do a division here, so it should be 250 over 1,000, and then if we kind of solve that using our math skills, 0.05 divided by we should have an answer of 0.2. Now we've got to remind ourselves, what's the unit for concentration? It is moles per decimeter cubed. So hopefully that made sense. I'm just going to run through it very quickly again. You've been asked to calculate the concentration of sodium hydroxide. They've given you the value for a volume and a value for the amount of grams. You can use the number of grams with this formula in order to calculate the number of moles. When you've calculated the number of moles, you have two pieces of information which allow you to use this formula to calculate the concentration, because you have moles and you have volume. So you plug in the values into the equation and you're going to get an answer of 0.2 moles per decimeter cubed. Now what I'd like you to do is this practice question. So you're going to need to pause the video to give yourself time to write it down and have a go at doing it. It's very, very similar to the last one. Let's look at what the values they've given you. Well, they've given you the concentration here and they've given you a volume, okay? So they're asking you to calculate a mass. So it's slightly different from my example, but very similar, except the unknown is different. The unknown here is the mass, whereas the unknown in this question was the concentration, but you're using pretty much the same technique. After you've done that simple one, we've got slightly more complex ones here. I want you to do these as well. So work through these, please. All the information is given to you there. Again, here, this is asking to calculate the concentration, okay? This is the one we've actually we've done a very similar one to this. I did that example, okay? So it's even with the same alkali, it's just got a slightly different value there. Then we got a slightly more complicated one there, just because you're using ethanoic acid, which is perhaps not as familiar to you, but the procedure is the same. And then part B here is just wording the question slightly differently, but it shouldn't be any more tricky, okay? So I'd like to work through all those questions. Again, you'll need to pause the video to give yourself time to see the questions and do the answers. You don't need to write down the questions here, or where was it? Here. It's not really necessary. As long as you show your workings and give a complete answer, I'm not requiring you to write down the question. Okay, good luck with that. I think that's probably enough for you to get on with today, and we'll wait until next class to move on to really understand the titration stuff that you were introduced to yesterday. Okay, have a great day. Bye-bye.